Hello students, I am Alfia, working as an assistant professor in Vailtech Multitech Dr. Rangarajan, Dr. Shahundala Engineering College. Today I am going to discuss about the topic Strategy Games, Prisoner's Dilemma and Matching Pennies in Game Theory. Before going to the topic, first we have to know what is game theory. Game theory is a study of how people make decisions where the outcomes depends on the actions of two or more individuals called players. So, game theory is mainly used for decision making. It is mainly used in businesses for decision making like setting prices, launching products and advertisement. So, game theory is also used in economics to study the competition between companies, pricing strategies and auctions. So, let me see some basic terms in game theory. First one is players. Players are decision makers. It may be individuals, firms or countries. Next one is strategies. Strategy is the plan of actions each player can take. Then payoff. Payoff means rewards or result based on the strategy combination. Then in strategies, in game theory we are using three types of strategies: pure strategy, mixed strategy and dominant strategy. First one is pure strategy. Pure strategy is the player always chooses one fixed action. So there is no guessing or mixing strategy. Consider an example of rock, paper, scissors. If a player chooses always rock, then we can say that rock is a pure strategy. This is an example of pure strategy. Then mixed strategy. Second type is mixed strategy. So mixed strategy is the player randomizes between strategies according to some probabilities. So consider the same example of rock, paper, scissors. In mixed strategy, rock, paper, scissors with 1/3 chance, because here the players randomize between each strategies. Third and last one is dominant strategy. So dominant strategy means a strategy that always gives better results than others. So regardless of other actions, here the player chooses best strategy for themselves. Okay, this is the three types of strategies. Next, this is an introduction about game theory. Next we are going to see what is strategic games. Okay, so strategy game is also called as normal form game. So in strategy games, players make decisions simultaneously without knowing what others will choose. So each player wants to maximize their own payoff and the results depends upon the combination of everyone's choices. For example, think of two companies setting prices for similar products. So consider an example, if you are having two companies A and B, so both are manufacturing same products. So both companies are going to setting prices for similar product. So in that case, there are three scenarios. If both set high prices, for example company A and company B, both set high prices means both earn good profits. This is one case. In next case, if both set low prices means company A and company B, both set low prices means both get less profit. Another case, if one company set low price and other get high price means, so the low price company will attract more customers and will get more profits. So this is the example of strategic games. Next, assumptions. There are some assumptions for strategic games. First one is players are rational. So rational players means they try to maximize their own utility. Utility means payoff. So rational player always chooses best strategies for themselves. Okay, so first assumption is players are rational. They try to maximize their own payoff. So second one is players should aware of all possible strategies and payoffs. So in strategy games, all players should aware of all possible strategies and payoffs. Third one is players make decisions independently, no collusions. No collusion means no grouping or no cooperation occurs. If we are having two players means two players can make decisions independently without collusion. Okay, collusion means grouping. Okay, cooperation. Without cooperation, so they make decisions independently. Then last one assumption is simultaneous or blind decisions. That means they don't know the other choices in advance, because there is simultaneous decisions moves is taken place. So there is they don't know other choices in advance. These are all the assumptions in strategic games. Then we are going to see what is the example of game theory. Example of strategic games. First one is prisoner's dilemma. So it is an example of strategic game. Okay. So consider the situation, consider a scenario. So prisoner's dilemma means two criminals, prisoner A and prisoner B, are arrested and they are kept in separate cells. They can't communicate to each other. Okay, no cooperation is possible between two. So they must decide whether to confess or stay silent. So there are two players, two criminals, player A and player B. Strategies are two strategies: stay silent or confess. So payoff matrix. Okay, so consider look at the payoff matrix. So A and B are two criminals. So stay silent and confess are the strategies for the players. So there are four cases. If both A and B both stay silent means each get 1 year prisons. Here the number in payoff matrix represents number of years in jail. Okay, so if both stay silent means each get 1 year prison. So it is good for both. Okay, in second case, if A confess and B silent. If A confess and B silent means A goes free, so 0 years, and B get 10 years because A is confessing. So A betrayed B, but B stays silent. B is cooperating. So A goes free 0 years and B get 10 years. In another case, if A is silent and B confess means A get 10 years and B go free. Okay. So both confessing. Okay. So both are betraying. So both are confessing means each get 5 years prisons. Okay. So this is a prisoner's dilemma explanation, payoff matrix explanation. So this is a strategy game because both players decide simultaneously and the outcome depends on both the choices. Next, finding Nash equilibrium in strategy games. So what is Nash equilibrium? So Nash equilibrium is no player can gain by changing their strategy alone. For example, what it means, if a player A changes to their strategy, he will not get better payoff because each payoff depends on other player's strategy too. Okay, so no player can gain by changing their strategy alone. So in prisoner's dilemma, both choosing defect is the Nash equilibrium. Okay, so even though both stay silent gives better result because if they both stay silent means each get 1 year prison only. But if they both chooses defect, they both get 5 years prison. So this is the case of Nash equilibrium because even though stay silent, cooperate gives better result. Each has an incentive to defect. So each player acts selfishly. Okay, so this is the case of Nash equilibrium. Then another example of strategy game is matching pennies. Okay, so matching pennies is a two-player zero-sum game with opposing interests. That means two players. In matching pennies, there are two players. Two players are going to flip a coin. Okay, so two players are going to flip the coin. Each player can choose head or tail. Okay, so each player can choose head or tail. If both the coins are matched, that means head or tail occurs means player A wins. So player A get +1. If they don't match, that means if head tail or tail head occurs means player B wins. So player B get +1 and A get -1. This is the concept of matching pennies. Okay, so explanation. This is a payoff matrix. So both head means, so same means both A and B both revealed head means, so A get +1 and B get -1. Similarly, if one head and one tail means, so A get -1 and B get +1. Similarly, tail head means A get -1 and B get +1. Similarly, tail same, so same means A get +1 and B get -1. The matching pennies is also called as zero-sum game because the total payoff is always 0. When we add the numbers in payoff matrix, it must be 0. So it is a concept of zero-sum games. Okay, so there is no Nash equilibrium pure strategies, but a Nash equilibrium in mixed strategies. In matching pennies, we don't have Nash equilibrium in pure strategies. we have only mixed strategy Nash equilibrium. So then we have to see what is mixed strategy Nash equilibrium. Okay. So in mixed strategy Nash equilibrium, each player randomizes over the strategies according to the probability. Okay. So no player, as I already said, what is Nash equilibrium? No player can gain by changing the strategy alone. Is a Nash equilibrium. Okay. So mixed strategy Nash equilibrium is here the player randomizes over the strategies according to the probability. Okay. So pure strategy means choosing one specific move. Mixed strategy means here the players can randomize over the strategies according to the probability. Then how to find mixed strategy Nash equilibrium? So in as I said earlier, so matching pennies only have mixed strategy Nash equilibrium. There is no pure strategy Nash equilibrium. So how to find mixed strategy Nash equilibrium in matching pennies? So let A place, so we have to choose some probability. We have to fix some probability for head and tails. So A and B are two players. So A plays head with probability P and tails with probability 1 minus P. Similarly, B plays head with probability Q and tails with 1 minus Q. So we are going to find the value of P and Q. Okay. So step 1, to find the mixed strategy equilibrium, step 1 is make A indifference between head and tails. So how to make A indifference between head and tails mean we are going to calculate the expected payoff for A when playing heads and tails. For if A plays head or tails, what is the expected payoff? First we have to calculate. So how we calculate means if A plays H, so here the probability into payoff. So what is the payoff in Nash? So in payoff matrix, if A plays head and tails, what is the payoff? 1 and minus 1. Okay. So 1 and minus 1. So what is the probability? Q and 1 minus Q. So probability into payoff. Q into 1 plus 1 minus Q into minus 1. So solving this we can get 2Q minus 1. Similarly, if A plays tail. What is the payoff? Minus 1. Minus 1 and plus 1. So Q into minus 1. So with probability. So payoff into probability. So Q into minus 1 plus 1 minus Q into 1. So solving we can get 1 minus 2Q. Now set both equal to make A indifference. To make A indifference, we are going to set both equal. That means 2Q minus 1 is equal to 1 minus 2Q. From this 4Q is equal to 2. So Q is equal to, we can get Q is equal to 1 by 2. So 1 by 2 means 0.5. So step 1 we calculate expected payoff for A when playing heads and tails. So B must play head and tails with equal probability 0.5 and 0.5 because B plays heads with probability Q and tails with 1 minus Q. So Q is equal to 0.5. So 1 minus 0.5 equal to 0.5. So B plays heads with 0.5 and tails with 0.5. Similarly, step 2. First we calculate step 1 making A indifference between H and T. Step 2 make B indifference between H and T. Okay. So now expected payoff for B. We are going to calculate expected payoff in step 1. We calculate the expected payoff for A. In step 2 we are going to calculate the expected payoff for B when playing head and tails. If B plays head, payoff of B is, what is the probability? So probability is minus 1 and 1. Okay. So P into minus 1 plus 1 minus P into 1. So solving we can get 1 minus 2P. Similarly, if B plays tail. See, if B plays tail, what is the payoff? If B plays tails, what is the payoff? Minus 1 and 1. So P into 1 plus 1 minus P into minus 1. So payoff into probability. For each we have to calculate the payoff and probability. So payoff into probability. So P into 1 plus 1 minus P into minus 1. So solving we can get 2P minus 1. So set them equal for indifference, then 1 minus 2p is equal to 2p minus 1. So 2 is equal to 4p, p is equal to 1 by 2. So similarly, A must play